I will talk about generative design for additive manufacturing. I think all these short names you already know. So we can talk with just letters, DfAM. So in footwear industry, there are some topics I want to share with you. This is like a tag cloud, but my topics are these. I will go through them, showing some projects. Because of the confidentiality, I cannot disclose so many customer projects. But framas started 75 years ago here in Germany, in Pirmasens, not so far from here, but far from where I come from. And now, nowadays, we are located in many locations. That's redundant. We have the headquarters here in Germany, but our mass production is happening in Asia, Vietnam, Indonesia, China, Korea, Taiwan. So we have many footwear customers. That's our business. And we basically do polymers or plastic injected parts for sport industry. And we have different departments. I'm sitting in innovation. By the way, my name is Rene, Rene Medel. But we also have some other teams. We do development together with innovation. We have our own mold shops and production, but everything started with the shoe last. The shoe last are this representation of your feet to design a shoe. And now we offer all these end-to-end solutions from the initial ideas or concept until final production. Many years ago, after some years framas started, this guy was innovating about shoemaking for sport industry, or for football, basically. So Adi Dassler was working with leather and invented this way of making studs using rubber or some other plastic. Now this nowadays is really different. We don't use much leather anymore, and we use some polymers, polyamides, nylon, or TPU. So that was the evolution, and what we have been doing is traditionally working in an implicit way for design. Computer-aided design. I'm an industrial designer. I'm not an engineer. I work as an engineer. Computational designer, I don't know. I use computers, as all of us. And I've been, like Aaron, like since ages, like working and programming basic things. But that helped me to now work in a more explicit way, so using generative ways of design, algorithmic design, call it as you want. But this optimization is giving you a lot of freedom, so you can use many inputs to create your own designs. Not in an implicit way or linear, but taking all these steps and making it visual and graphic, so you can create an algorithm and you can tweak these components and elements, and you will have different results, iterations, and you can really design with the help of the computational design. Something I've been using lately quite often is SubD topology. It's not new, it's older than me, but the way of simplifying meshes and the algorithm showing this as a SubD in a very smooth way is simplifying the way of how the computer works with this geometry. It's very simple to work with, and if you combine this with generative design, you can have this generative SubD, which is giving you a very good result, but with very low computational demand. So even if it's CPU or GPU, you can work with algorithms in a very simple way to generate iterations of many ways. Sometimes it's very simple. You saw very complex algorithms from Aaron or Jesus, but this is I'm not an expert, so I do really simple things, and the way of learning is also taking something that someone did before. And that's maybe something about the community Aaron was talking about. Grasshopper is really open to collaborate. So that's why I am not an expert, but I learn a lot from taking what someone did before, so I don't need to start from scratch. This is basically the way that you can work with SubD, if you're not familiar. For footwear, it's really good because you can create with a lot of freedom, but also with accuracy, and you can have some elements. Now, for example, with crease, you can control the radius, which is not a real fillet. It's more a value, like conic curves. It's geometry, but taking this into a next level. And this enables new ways of designing, but also manufacturing traditional shapes like a shoe last. Is a very organic shape because it's following the shape of the foot. But it has a lot of measures and dimensions. And this project last year was special because we did it really in only 3 days. You know, maybe you don't know, but traditionally to make this shoe last, it needs a lot of manual work. So you need to carve this wooden block or plastic block and remove a lot of material, and then to achieve all these measurements is not so easy, so you need a lot of practice to do this. But now the digital last came really easy using, for example, this SubD topology, and gave us the opportunity to release this shoe last for free. And then we realized that some young designers are using virtual reality for creation, Gravity Sketch, for example. So we need to provide also solutions for these new designers to be able to have not only a physical last, and nowadays we're having more customers asking for just a digital last. We don't need a couple of kilos of plastic to design a shoe. But you can use the physical last. And some others are more traditionally working in the physical last, taping or masking tape, drawing on the last, and then, in this case, the winner of the Laceless Challenge did it like that. We gave him a prize, so he was developing his own last in our facilities. And that was a really cool project in a very fast development. Some previous presentation talked about lattices. Metamaterials, you will know more better later with coming speakers. But lattices should be obviously functional, is kind of discrete, so you can control it. Some designers think about structures in a different way of engineers, but everything needs to be optimized for production. And now this production, in the case of lattices, is additive manufacturing. Otherwise, we cannot create this. So there are new tools, like Crystalline Aaron was showing, and beam lattices are fine, but now we also have not only TPMS, but ADMS, or adaptive density minimal surfaces, as you will see with Sphyrine. And not only for saving weight, but also saving energy. Being sustainable is also about using less energy or energy consumption. And in that sense, you can also go deeper into remove most of the material inside to make it strong enough, but with minimal wall thickness, for example, or minimal structures inside. And this I like very much because Sering is doing a great job comparing to gyrodes or TPMS. With ADMS, you can really have isotropy, so the forces are working much better, and the distribution, the geometric distribution is better. Some other interesting project, this is a work in progress, but a company from here, Berlin, auf Augenhöhe, they make fashion, let's say, for small stature people. So, and they wanted to create some shoes because, you know, these people, they cannot find regular shoes. It's like a kid shoe, like for children, but it's not fitting because it's much wider. So we developed this new last, and we had the opportunity to validate this last during the Olympic Games, let's say, in Cologne, here in Germany. So finally we did it digitally, but this is the, it's not a shoe, it's just a fit tester. So it's not a shoe, it's just to fit and to know the measures of, some measures of the foot compared to the last. But we also did the foot scanning, and in that case, we have the two inputs, so we can compare. Now the challenge is to take all of this fit and use them as an input for improving the shoe last. This also gave us a starting point to talk with some other partners like Sverin. So we started thinking about what if we, at framas, we create our first full shoe, because we don't make full shoes. We only make some components, but using 3D printing, we could do. And using technologies like Sverin, I created this. You can see the samples back there. So the important thing is about combining topologies like SubD together with meshes coming from Sverin in a way that finally you can shrink wrap everything and make it watertight for 3D printing. So anyway, if you use SLS or SLA or FDM, as you can see here, it's working for all these kind of 3D printing processes. Using pellet directly, you can see the samples there. From Carbon today, thank you Carbon, they brought a couple of, a new pair using EPU 46 foam, right? Good. And we have done some SLS testing with powder, PLA, you name it, and finally you find a way to print it with less supports, no supports inside, so it's quite interesting. Using time, you can also run some ways of form finding. Sometimes it's very simple, just to have the connection of the threads through points or to nails, just to show an idea, but with some physical properties like the length of this thread. And it's an algorithm, it's very simple, but it's useful so you can put some numbers behind. And in this other case, you can leave it running until it's growing, this venation system. And well, this is not, yeah, it's venation in Grasshopper, so you leave it in time and then it's growing and you can have some patterns or textures or structures or whatever you want. But the cool thing is that later you can fabricate this. So I took the same idea, and the challenge was to avoid, well, to make a real mold for production, and to avoid some sensor points in the mold, and doing this venation again, leave it growing, but avoiding this point. And the SubD geometry should be injected, so we run the analysis for mold flow simulation. And surprisingly, it was really good because finally the CAM software took this file in a much better way, light files, very simple geometry, and flawless, no geometry issues like naked edges or watertight or whatever you want. You should have using meshes or surfaces, nerves, but in this case it's running really smoothly. Some are simple cases. Analysis, I'm not an expert, I don't do, I just do basic thickness analysis, but now with tools we can also use remeshing with shrink wrap, so you can turn, not trash, this is not trash, but it was coming from simulation. It's a gas flow, so gas is creating these crazy meshes, and you can simplify it and making discrete in the way that you want, or working with conformal cooling for cooling these molds, because finally every second we win in reducing the time of cooling. For us in mass production, you can tell it's a lot of time, and saving energy and time is always good. Using 3D printing, we're also creating some molds for, not for injection molding, but for foaming. So foaming is not so demanding, it's exothermal reaction, but up to 80 degrees, so it's not so hard, and the clamping forces are not so strong, so we could use even SLS for printing molds like this, for running some sample tests to validate or to make some proof of concept. It's good enough. In digital creation, you can use many tools. Now extended realities are improving the way that we could create, and we can also visualize our projects. In some cases, some customers, they want to work with virtual reality for creation, so you can get these projects from customers, starting with virtual reality, and we need to be able to provide not only the traditional way of producing as we know how to do, taking it from the CAD and then doing as we know how to do it, but also somehow collaborate in this new environment, this is virtual reality, but also providing the shoe last, so they can start creating, as I show you with the laceless challenge. The output could be also VR, virtual reality, or augmented reality, which is more democratic because you can use it in your devices you have already in your pocket. There's a couple of formats or standards, so depending on which side are you, Apple or Microsoft or Android or etc. So USD or GLTF now are the two standards, so you need to have them both if you want to go with Microsoft tools like PowerPoint that you're showing now. This is a 3D model, it's not a video. I can go back, so this is just a 3D model. To show this in a presentation like this, but you can also use it in, as I said, in devices that you already have, so you don't need to wear any goggles or doing some crazy things. So, well, if you have the money, you can do it, but with your smartphone, tablet, you can show and compare some real physical products with digital twins or digital models. Artificial intelligence is another topic I'm not an expert, but I've been doing some tests. I'm also not an expert in coding or programming, but I know now how to ask with the right prompts. You can have some simple codes or coding or programming for doing something else, but you can also do it for research, for inspiration, for ideation. So you can use text to generate image, or with the same image you can make more images with just a simple sketch. You can make renders. Now from an image you can make video. From image you can make 3D models. You can almost do everything. Important thing is to understand that these models are large language models, so you need to train the model. Train yourself and train the model, so then you will get the right results. Of course, these shoes are not real, so just inspiration. But as I said, text prompt can give you coding in a very simple way, just Python. I don't know nothing about Python, but I can now make my own codes, or you can research about patents, intellectual property, market research, etc. And nowadays, generative AI is also interesting. I will not do any demo because I know it will fail if I try to do it live. But this is me as a woman. I was showing to my webcam one shoe, which is not this shoe, it was any shoe. And this is what you can have with a prompt. But generative is every millisecond or every second you're having many images. It's amazing and mind-blowing what you can get with this. Or you can use some other tools like Leonardo or Midjourney or whatever you can use. These are just some examples. Again, this is not improving the way that you can design, but it's helpful for different stages. It could be just for ideation, creation, inspiration. If your visual skills are not so good, you can also show this to someone else, and then you can generate something else, because you know one image is very powerful, so you can create many things. I had a final slide with conclusions, but I prefer not to show it. I will say at the end we are kids just drawing shoes. So thank you.